Welcome to grade 9 math. We're in unit 5 of measurement and we're in starting lesson 7 of maximizing area. By the end of this class, you'll be able to determine the maximum area of a rectangle with the given perimeter, and you'll be able to solve problems that require maximizing an area of a rectangle with a fixed perimeter. Okay, so let's just recap how to find our area on a regular basis. So again, area is length times width. So area is 1 times 6. The area is 6. Okay, what about this one? So area is 3 times 4. Area is 12. And these are our centimeters squared. Okay, area is 2 times 5. Area would be 10 centimeters squared. What do you notice about each rectangle? So look how the area changes depending on the shape of it. So which one gave us the largest area? And is there something significant about its shape? So that's what you want your mind on is there a significance to 12 was the greatest area, and what difference do we notice about the shape of 12 versus the other two? All right, let's move ahead. Well, we're going to figure out by doing an investigation. Now, ideally, you would have done this ahead of time. You would have tried it with a partner or tried it on your own. We're investigating the border of 4 sides. Your neighbor has asked your advice about building a garden. He wants to fence the largest rectangular garden with a set number of fencing. Like he has 40 meters of fencing. That's all. And he wants to make the greatest area. That's what you'd want to be efficient, right? You'd want to have the least amount of perimeter, but the greatest area. Because if your area got bigger, you'd have to buy more fencing, stuff like that. Okay, so we need a reminder that this is one way to do perimeter over here, and one way to do area. And so I already we already built this table so that it solves our problem easier. So we complete the table. Remember the perimeter for each rectangle has to stay at 40, and the first 2 rows are done for us. So what is this all going to do? So notice how this is built. We know that perimeter is 2 times its width. So here are our width values. If we put the width value into here, okay, then we put the 0 in there. And after we figured out the 0, we'd get the 20 here. This 20 got put here. Okay, so that brought over here. All right, this 0 was the 0 that went in here. When we enter the next line, right, we see the 2 in here. We get a result. We see the result in here. So let's follow that pattern. Now we got to use our calculator. And so we'd have to do 40 minus 2 times 4 is 8. So 40 minus 8 is 32. So 32 divided by 2 is 16. Well, 16 goes here. 16 times 4 is 64. Okay. Pause the video, try a few of these on your own, and then start it up again. We'll take them up together. All right, we'll try again. So if you're having a hard time, let's take the next few up. So again, 40 minus what will be 12. 40 minus 12 is 28. Okay, so we're going to have 28 divided by 2 is going to give us the number that goes in here, actually. 28 divided by 2 is 14. 14 times 6 is 84. So notice what we're doing here. The 0 here is the 0 that's there also. The 2 that's here is the 2 that's there. So notice that these numbers are coming in here also, because that's our width. And we're figuring out our length on this column. Okay, what if this was 8? So 40, what's 2 times 8? That's 16. That's going to give us 24. 24 divided by 2 is going to give us 12. All right, look, this stuff disappeared. So what are we going to do? So where did we get the next number? This number. Well, it came from the width. So it's the width times the length. So we've just figured out the length. Now we go back to the width. What's 12 times 8? 192. No, that's not right. 12 times 8. 96. Okay, we put the 10 in here. All right, well, 10 and 2 is 20. So 40 minus 20 equals 20. And 20 divided by 2 is 10. 10 times 10. Okay, so what's 10 times 10? Well, that gives us 100. All right, we keep going. So look, they took away this equation, but everything has stayed the same except for what's in the bracket. So 40 minus 2 times the number divided by 2. Well, the number is 12. Okay, so what's 2 times 12 is 24. So 40 minus 24 equals 16. 16 divided by 2 equals 8. So 8, remember that always showed up there, and then we went back to what number is here, times 12. 8 times 12. Well, look, we actually know that up here. So it's the same, but it's just reversed. Okay, 40 minus 2 times 14 divided by 2. Okay, well, what's 2 times 14? So 2 times 14 is 28. 40 minus 28 equals 12 divided by 2. Well, 12 divided by 2, that's easy enough. 6 times, take this number again, 14. So it's length times width. And what do we get? So 6 times 14 is 84. Huh, I see a bit of a pattern happening here. I think that's going to be important. 40 minus 2 equals 16 divided by 2. What's 16 times 2? It's 32. So 40 minus 32 is 8. 8 divided by 2, right, is 4. 4 times 16. Well, what's 4 times 16? So 4 times 16 is 64. The pattern continues. Look, it peaked at 9, so it went up to 96. Now it's going down to 64 where it was already there. All right, so you can probably guess what's going to happen next. All right, do these last two ones without me. Pause the video and try it. All right. Okay, let's keep going. 18, 2 times 18 is 36. So 40 minus 36 is 4. 4 divided by 2 is 2. And we're multiplying that by 18. 18 divided times 2, 36. All right. And we're on our last one. So 40 times 2 times 12, or minus 2 times 12 is divided by 2. Well, this one's easy. What's 2 times 20 is 40. So 40 minus 40 is 0 divided by 2, which is 0. So at 20, we have 0. Think about that. That would be a flat fence. 2 pieces of fence back to back. All right, so now we can graph these. Now they've given us the equation. What would be our points? Well, now we know our length and our width. And it actually wants to know your width and area. Notice that this is area. So at 0, we're at 0, right here. At 2, we're at 36. 2, 36. Oh, that would be around here. 4 and 64. 4 and 64. 6 and 84. 684. 8 and 96. 8 and 96. Yeah, we're checking all these off. We got them all. Good. 10 and 100. Remember, that's kind of where it peaks here. Might be important. Okay, 12 and 96. And we're repeating ourselves. So 14 and 84. 14, 84. 16 and 64. 16 and 64. 18 and 36. And 20 and 0. Okay, so what does it look like? We just did not long ago, curves of best fit and line of best fit. So draw the relationship, draw the curve. So the curve is kind of like going up, 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 peaking and coming back down. Okay, circle the area with the largest. So we would, where is the area the largest? Up here. We call this the vertex, where it's the largest. And what's the dimensions? Well, it's at 10 meters and 100. 10 meters of width makes 100 area. All right, what conclusions can we gather? According to the graph and table, what are the dimensions of the largest rectangular garden that a neighbor could create for 40 meters of fencing? While looking again, what are the dimensions? 10 width for 100 area. But what is the length? If we don't know the width, what's the length? Okay, so we need to look here at where we got our answer. Okay, so if 10 was the width and 100th was the column. So what was the length then was 10. All right, so what's the dimensions? Dimensions are width of 10 meters and length of 10 meters. So guess what? If you make the garden a square, so I want you to remember that. Okay, a square is most efficient for a four-sided area. All right, so remember that. All right, let's take another different example. Here we have we have fencing, but it borders 3 sides and not this dashed line. City planners wanted to design a swimming area at a local beach. There was 100 meter of rope available to enclose the swimming area. The shore will be on the side of the swimming area. So you only need 3 sides of the rectangle to be roped off. Obviously, don't rope on the beach. So if your job is to design the largest rectangular area, all right, complete the table. So there's going to be so we did learn in the last example that squares are the most efficient way to get the biggest area. This isn't, that's the rule almost all the time when it's 4-sided. objects. This is going to show an exception to that rule when we only have 3 sides. It might not be a square. It might be a square. We're going to see. Okay. So, all right. Here we have the width. The length is just basically the perimeter equation reworked. And the area equation is still length times width. So, here we say we put this into here. Okay, and we get 100. Then the 100 goes into the length, or into the width. And the length is, we're not, is here, okay? So they did the first one for us, so we can say 0, 0, and 0. Next, we put, again, the 10 into here, and then the 80 comes there, and the 10 repeats itself. And we got 10, 800. So 10, 800. All right, let's try. Now we have to do the math ourselves. So what is 20 times 2? 20 times 2 is 40. 100 minus 40 is 60. That 60 goes right here. 60 times 20 is, punch it in to make sure, 1,200. So at 20, we're going all the way up to 1,200. All right, next. Well, what is 2 times 30 is 60. So 100 minus 60 equals 40. The 40 goes here. The 30 is the same 30 there. And so what's 30 times 40? Punch it in just to make sure. It's also 1,200. Good. So we have 30 and we go up to 1,200. All right. Oh, that didn't right. Next, we put the 40 in. Now they're giving us more work to do. 2 times 40 is 80. Okay, so 100 minus 80 is 20. 20, that number becomes here. 20 times that number, 40 is 20. 20 times 40 is 800. And we see the pattern repeating itself now. So 40 and 800. And last, at 50, what is 50? Well, 50 is going to, 50 times 2 is 100. 100 minus 100 is 0, of course. 0 times 50 doesn't matter because it's going to be 0. Okay, so we're down here. All right. Now, we know that these things peak, so we might be okay to say that this is where it ends, but my hunch is that it probably continues because it's going to go up, 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 peak somewhere, and come down again. Oh, let's try that again. So actually, before we do that, let's try this idea. Let's try in between. Since this is 1,200 and 1,200, right? What's halfway in between? 25. 25. So why don't we try it? We'll add another column here. If it's halfway between 20 and 30, we're going to might as well test out 25. So 10 minus 2 times 25 equals, well, what's 2 times 25? 2 times 25 is 50. So 100 minus 50 equals 50. And then remember that's the number we bring here. So 50 times 50 is 50 times 50 is 2,500. No, that can't be. What did we do wrong here? Oh, times 25. Yeah, we're bringing this number. Okay, so sorry, we brought the 50 from here, the 25 from here. So 50 times 25, that would have been way too huge. 1250. So it's not much of a difference. That goes, so at 25, it's at 1250, and these are going by 100s. So that's halfway at least. All right, and we can bring our curve down. All right, so we have a vertex, a peak, or max of at 25 and 1250. Very good. So what are our dimensions then? We're trying to draw, again, width. So we're looking at a roped off area. Oh, should be 90 degrees probably. And we have our width and our width and our length. Well, from the dimensions, this was the best example. So our width should be 25. That's our width. And our length should be the 50 because that's what we used for L. So 50, 25, and 25. So therefore, to maximize the area, no, well, let's just area for swimming, the rope dimensions should be 25 meters by 50 meters. So what else do we notice about this? 25 and 50. In order to, here's the catch. Here's the rule of the exception to the rule where a square is best. Obviously, this isn't a square. So the rule is that the length in three sided areas rectangular that is, the length is twice, no, let's say double the width. And that will give you the maximum area every time. Okay, so we sort of follow that exception to the rule. Okay, so given that we know this now, we know that four-sided rectangles, a square is the most efficient. Okay, and that if we had a three-sided object, we would have the best area would be if the length is double the width. And there's, okay, so when a border is needed on all sides, a rectangular enclosure, the dimensions that will create the maximum area for a given perimeter is that when the length is equal to the width. In other words, a square. In general, the closer the length is to the width of each other, the greater the area. So sometimes you're going to have questions where you can't do that. So you just get as close as possible to the square dimensions. When the border is needed on a three-sided rectangular enclosure, the dimensions that will create the maximum area for a given perimeter are length equals 2 times W, so twice W, when the length is twice as long as the width. In general, the enclosure three-sided rectangle is to these, the closer the three-sided rectangle is to this dimensions, the greater the area. Determine the maximum area. So example number 1 for our lesson. Determine the maximum area of a rectangle enclosure with a perimeter of 96. Now, a couple definitions here. A rectangle um, is not a square, but a square is a rectangle. So squares are in the family of rectangles, but a rectangle can't be a square. A square is a special rectangle. Okay? Square is a special rectangle. Rectangle just means a four-sided object with 90 degrees. Okay, so rectangles can be many, many different things, but but rectangles cannot be a square. Okay, a square can be a rectangle. Determine the maximum area of the rectangle enclosure. So max, we know we're going to use a square. Okay, so how are we going to do this? So the thing must be a square and we have a perimeter. So what is perimeter? Perimeter is equal to a side 1 plus side 2 plus side 3 plus side 4. But if we know it's going to be a square, okay, if we drew a square and all the sides are equal, and we have 96, perimeter is 96, how are we going to find out what each of these are? Well, divide by 4. And that's what we're going to do. So actually, we didn't have to write all this, but we're going to say the perimeter is 96. So we're going to say 96 divided by 4 is 24. And I just did, do that in your head or in your calculator. Okay. So if one side equals 24, okay, then the length equals 24 and the width equals 24 because we said they'd all be the same. That only brings us, so now that we've sort of done all this thinking, we can find our area. So area equals length times width. So area equals 24 times 24, which means 24 squared. Or you can write it as that, 24 squared. So what is 24 squared? 24 squared, punch it in your calculator, and we have 576 meters squared. There we go. That's the maximum area you can get with the 96 perimeter of fencing or whatever they want to do. And if you're going to go to Home Depot and buy fencing, you want to make sure you're using it, minimizing how much materials you need to buy. And then you want to get the most area for that. Okay, so here's another example. Jillian is building, it's going to be a three-sided one. All right, Jillian is building a rectangular enclosure for her garden. One side of the garden is bordered by her house, so you don't need border. So she doesn't need any fencing on that side. What are the dimensions of the largest rectangular garden she can make? Okay, so here's her house. Here's the fence. She has the length and the width and the width. Now, she's given a perimeter. Perimeter equals 18 meters. So she's allowed to use 18 meters. Okay, so if the perimeter is going to be the width plus the width plus the length. Now, when we look back to our note, what did we say that equation was? Well, we said, no, where is that? It's at the top of, sorry about that. It's at the top here. So length is equal to 2w. So going down here, I like to think of things as algebraically. So perimeter equals w. So we could say that length is equal to 2w plus w plus 2w. We put that in there. All right, well, we know how to collect like terms, and these are all like terms. We have 1 plus 1 is 2, plus 2 is 4. So the perimeter is now equal to 4 w's. Almost as if right here we had another w and another w. So there's 4. 1, 2, 3, 4. Kind of like dividing them all up. So I'll show you another quick way in a second. So let's substitute this in. 18 equals 4w. And so we need to divide both sides by 4. Imagine if we did that at the beginning, we might have a clue here. 18 divided by 4 is not a nice number, but it's 4.5. Not bad. Okay, so now we know the width. The width is 4.5. What's length? Well, length is 2w. So length is 2 times 4.5 is 9. Very good. Now, secondary, that gives us the dimensions, but I wanted to show you this. Let's say we know this is the case, that L is equal to 2Ws. We can still take this idea that 18 divided by 4, because look, it's like 4 segments. 1, 2, 3, 4. It's going to give us the 4.5 right off the start. And then we can say, oh, okay, that's 4.5 and 4.5 and 4.5 and 4.5. Well, together these are 9. And then you could figure out that way. Anyways, well done. The dimensions of the garden will be 4.5 meters wide and 9 meters long. And there we go. So you understand that the best thing to do to get the maximum area as a square when you have a four-sided area or four-sided structure, and when you only have a three-sided area, because there's lots of different ones. Like think about, like the garden, building it up against your fence. You don't need to put fencing up against your brick wall. Okay, or the beach example. So you have different examples here, different ways to find the largest area, which one is the greatest area. Again, something that's closest to a square is probably the greatest area. Okay, some problems now you can try. Here are some with three-sided ones to practice. Those are always really good to practice. And then here making a dog fence. What would happen? All right, so just to recap, that rectangles can have the same perimeter but different areas. So a rectangle with a border of 4 sides is the largest area is when it's a square. Okay. The closer the rectangle's dimensions are to a square, the greater the area will be. If you have a rectangular enclosure with 3 sides, the largest area will be when the length is twice of the width. The closer the rectangle's dimensions are to that idea, the better it will be. All right, thanks for watching, and good luck on your practice. We'll see you next time.